In this lecture, I am going to discuss about different types of errors that can occur during the execution of a Python program and ways of handling them. Now, the errors are the mistakes or faults that cause the program to behave unexpectedly. So, by this unexpected behavior, it can refer to an erroneous output, or it may also refer to an improper termination of the code in between the execution. Now, based on the reason for which an error has occurred, it can be classified into certain categories. So, one of the categories is called syntax error. So, the syntax error is caused due to the violation of the syntax of the defined language, or in the language that we are writing the program in. Now, syntax errors are symptomatic. That is, whenever there is a syntax error in your code, the compiler, or in our case for Python programming, the interpreter, will be providing us with an error message that there is a syntax error, and after getting that, we need to fix that syntax error. Now, a code with a syntax error will be resulting in an immediate termination of the execution of the code, and it will not produce any output, anything. So, any part of the code will not be getting executed. I will be showing you a code having a syntax error in a short while. Now, the second type of errors that can happen while execution of a Python program or any programming language is called semantic or logical errors. This type of error is caused by the improper use of the program statement in your program. A semantic error can be symptomatic, or some cases it can be asymptomatic as well. That is, some semantic errors will be symptomatic. That means those errors will be showing us some messages by which we will be able to understand that there is at least some semantic or logical errors in our code. For some other cases, when the semantic errors are an asymptomatic one, it might not be providing us with any error messages, but the outcome or the output of the program might be an erroneous one. That is, it might not be providing us with the correct output in that case. In case of symptomatic errors, the execution of the code will be terminated immediately whenever there is a symptomatic error. For asymptomatic ones, the execution may continue, but the output or the output produced by your code will be an erroneous one, as I said earlier. Let us look at a program where there is syntax error. In this code snippet, I am taking the name and age as input from the user, and then I am checking whether the age is less than 0 or not. In case the age is negative, I want to print this error message, or this message to the user, indicating that an age cannot be negative. If you look closely at this code, there is a syntax error. I have written the same code here. So, if I execute this, you will be able to see that there is a syntax error which is at this point. Specifically, I have missed one colon which should be here. So, this is a type of error that is called syntax error, as shown by the Python interpreter here as well. So, as we have seen from the example, the program is giving us this syntax error message, and the program is not executing at all. By saying that, I mean that there are actually 4 lines of code. The syntax error is occurring in the third line, but the first and second line is not also getting executed because there is a syntax error. The second type of error that I have mentioned is called the semantic error. Here is an example of a code snippet having only 3 lines, which is syntactically correct. That is, there is no syntax error, but it is containing some semantic errors. So, let us try to execute the same code here. So, you can see I am taking the radius of the circle as input, and I am computing the circumference of the circle having that radius. I will request you to look at this code and try to figure out what's happening here in this code that is not actually the right thing to do. So, if I execute this one, you can see that it is actually the first line is getting executed, that the program is asking for the radius of a circle as input from me. So, let us provide an input say 4. You can see after providing the input, it is giving me with a type error, and the type error is saying that it can't multiply sequence by non-int of type float. Basically, you can see, as we have seen, that input by default will be taking the input from the user as string. So, the type of R is string, and here I am multiplying one integer with a floating value, which is possible that we can do, but we are also multiplying the same thing with a string variable, which is not actually possible. This is the reason this type error is getting occurred. So, this is an example of a semantic error or logical error, because what we are doing wrong here is a logical error. As you can see, we need to typecast this input, then only we will be able to get the desired output. But as we are logically doing this thing wrong, this is called the semantic or logical error. And also, as you can see, we are getting this error message. This is an example of a semantic error, which is a symptomatic one, that is, it is providing us with a message that we are doing something wrong. Now, in the second set of examples of the semantic error, here I have given two program snippets. In the first program snippet, what I am doing is I am taking two numbers as input from the user, and I am summing them up, and I am printing the sum of the individual numbers. Now, if you look closely, the program is not actually doing what it is supposed to be doing. I am taking the input. Note that I am not actually typecasting it. So, by default num1 and num2 will be strings, and whenever I am applying this plus operator on a string, it will actually concatenate the output. So, if I execute the code, enter the first number, let us give 12, enter the second number, let us give 34. You can see the sum of 12 and 34 is 1, 2, 3, 4, which is not actually the integer summation or the numerical summation that we want to do. So, this is an error, which is of course a logical error. We are messing things up logically, but as in the case of the earlier example, it is not actually providing us with any error messages. It is providing us with an output, but the output is an erroneous one. In the second example as well, what I am doing is I am taking the circumference of a circle as input. I am typecasting it with the float function. So, C will be of type float. Then I am trying to print out, I am trying to compute the radius of that circle. Now, if you look closely at the program snippet here, particularly in the second line, you can see I am dividing the circumference, which I have taken as input from the user. I am dividing that by 2, and then I am multiplying the value, the value of the division after performing the division, by 3.1415, which is an approximation of the value of pi. So, there is a logical error here, as you can understand. This 2 into 3.1415 should be in bracket. So, if I execute the code here, so you can see, you will be able to see that it is actually providing us with an output which is not actually the desired one, which is a wrong one. Now, to make it correct, what we need to do is we need to provide this bracket, and if I input the circumference as 88, the radius will be somewhere near about 14. But as you can see, without this bracket, the program was not providing us with any error messages. although this is an error, but as it was a logical error and it is an asymptomatic one, it is not providing us with any error messages. However, it is providing us with an erroneous output. Now let's look at another scenario. Let's consider a program that would take a file path as input and print the content of the file on the screen. Now, as we have seen earlier, to read a file, we need to open the file in R mode. R is specifying that we will be applying the operation read in the file, and we need to pass either the absolute path or the relative path of the file which we want to read. There are number of ways of doing this. Here I have specified 3 ways. By default, if you provide only the file path with the function open, it will be considered as it's a read mode. We can specify explicitly the mode R here with a string, or we can specify the mode using this mode parameter here in this way as well. Now let's try to write that code. First of all, what we need to do is we need to provide the file descriptor with the open function, and we need to provide the name of the file. So let's provide say input.txt. Note that I have stored one file that is called input.txt here, which is containing this text. This is a sample file containing some text. So this string is written in this file which is named as input.txt. Now I have provided the path of the file. This is the relative path. I can provide the absolute path as well, which is home /doipayon and then / the file name. So what I am saying is I can provide this as well. So this is called the absolute path of the file. Now to read the file, what we need to do is we can provide some content, some variable say content equals to say f.read, and if I want to print, so as the program statement wants from me, it wants to the program should be printing the content on screen. So to print the content, what we need to do is we need to provide this statement, and finally, as I have mentioned here, we need to close the file explicitly by using the f.close function. Now if I execute this, you can see we are getting the output which is exactly the same as the one that is written in this file. So this is a sample file containing some text. If I modify the text here, this is another line, and if I save it here, and now if I execute this program again, you can see this is the first line of the file and this is the second line of the file that was written in the file. Now let's try to change the name of the file. So say I have modified the file name as input2.txt. Now if I look at this place, there is actually no file which is named as input2.txt, which is a new file that I am getting that I am creating here. So there is no file that is. Now let's try to open one file which is not actually present. So if I provide this file name input2.txt, which is not actually present in this directory, and if I try to execute this, you can see I am getting one error, which is file not found error, which is specifying that no such file or directory is present in this path, the path which I have provided here in this program. Now if you try to look at the type of this error, this is neither a syntax error nor a semantic error. It is not a syntax error because with this code, whenever it was input.txt, that is when this file is actually available, it was providing us with the correct output, and whenever I am changing this to some file path which is not non-existent, so it was providing us with this file not found error. It is not a semantic error as well because we are not doing anything wrong logically. So, in brief, this is neither a syntax error nor a semantic or a logical error. Now, let us look at another example of the similar type. Here what I am doing is I am defining a function that is taking two parameters a and b as input, and the function is expected to be returning the value after dividing a by b. Now, if I call this function with the parameters 17 and 3, let us look at what we will be getting. So, this is the function that I have written. So, now if I call this function with the parameters 17 and 3, so what I want to do is I want to get the output of the result after dividing 17 by 3. It is providing us with an output as 5.66667. Now, if I want to call this same function with a parameter with parameters say 31 and 0, can you guess what will be the output? So, if I execute this, we will get one error which is specifying that 0 division error. So, division by 0, which is not possible, is arising this type of error, which is neither a syntax error nor a logical error. So, these two are, as we have seen, are not the only types of error that can happen, that can take place while execution of a code. So, there is another third type of error, that is called exception or errors at runtime. Most of the cases these exceptions are symptomatic, that is, they will be providing us with some messages indicating that there is an error. In case of our examples, in this case, when we are calling this division function with 0, with 31 and 0, it is causing that division operation to be performed with the second operand as 0, which is causing this 0 division error message. In earlier cases, when we wanted to open a file which is non-existent, it was providing us with an error which is called file not found error. So, this type of exceptional cases may cause due to some intermediate operations or intermediate inputs. In our cases, whenever I am providing with the second parameter as 0, it is providing us with this error. In the first example, when I am providing us with this file path which is non-existent, it was providing us with an error. So, some part of the code, if there is I mean, for this type of errors, some part of the codes will be getting executed, and whenever this exception occurs, it will be causing the termination of the execution of the program. To briefly summarize the difference between a syntax error and an exception, syntax errors are errors which are caused by wrong syntax that may lead to the termination of the code, the termination of the program altogether. This was an example where I have missed the colon here, which will provide us with an immediate error message, that is called syntax error, and the whole program code snippet will not be getting executed. Whereas exceptions are those cases where due to some intermediate computation or intermediate input, the program is facing some unexpected situation and it is getting terminated. But note that the syntactically the program is correct, then only it is called an exception. So, this was an example that we have already looked at. So, here this program snippet is taking two numbers as input. This program will be working properly only if and only if I am not providing the second input as 0. If I am providing the second number input as 0, it will be causing us with a 0 division error. So, while writing our code so far in this course, we have already faced some exceptions. For example, uh, if I declare a list containing 4 numbers 1, 2, 3, 4, and if I try to access the 4th position which is not actually present here, we have we have received this index error from the Python interpreter. If I try to typecast this list into an integer, we will be getting. I hope if you try, you have already seen this. It will be providing us with another type of exception that is called type error. The third type of exception that I hope you have already received is whenever we tried referencing a non-existing variable. So, if I do not have a variable defined that is called x, and if I try to print the value that is stored in x, it will be providing us with an exception that is called name error. And if I try to say mix the data types for some operation, for example, here I want to divide, I want to get the quotient after dividing 10 the string with the integer 2, it will be providing us with a type error. Here the erroneous statement is here, it should be 10, not string 10. In brief, these 5 types of errors or exceptions I hope we have encountered at some point of time during this course. Now, whenever this type of exceptions occur, the Python interpreter immediately stops the execution of the current process and passes the program flow to the calling process where it is expected to be handling the exception in some way. And if specifically the exception is not handled explicitly, the program stops execution. Now, I will be talking about how to handle the exception programmatically by writing some codes. Now, in Python, exceptions can be handled using a keyword that is called try, and the critical operation or critical region of the code from where the exception can arise should be placed inside a block that is called this try block or try block statements, and the code that handles the exceptional cases should be written in another code block that is called except block. In the except clause, we can actually choose what operations we want to, what operations or what execution of statements we want to perform once this exception occurs and once they are caught in this except clause. So, in brief, there will be 2 sets of blocks of codes. The try block, in which we should be writing the statements from where the exceptions can rise, and in the except block of program statements, we should be writing the codes to handle that exceptional situation. Now, let us look at the same example where I am taking 2 integers as input in 2 variables a and b, and I am printing the value of the result after dividing a by b. As this statement can create one exceptional situation, I am putting this statement inside this try block, and the corresponding exception handling statement I have put in this except block. Now, if I execute this, you can see, enter the first number say 12 and the second number say 5, a by b is 2.4 and done is getting printed. Now, say I have provided the input say 34 and the second number is say 0. You can see in the earlier case, this input would have caused an unexpected termination of the whole code, and this statement would not have been printed, because after execution of this, it would have been creating this 0 division error, and the whole execution would have been terminated. But here what I have done is I have put an except block where any exceptions that may occur from here will be handled from here, from this code statement. In this example, what's happening is this statement, there is some error in the input, will only be executed if there is some errors happening inside this inside this try block. Now, let's execute this once again. So enter first number. If I say give and so it is actually expecting one integer from me. If I provide say something, a string like QWERTY, you can see the execution straightforward. So it is an exceptional case. So the execution flow straightforward jumps from the second line to the sixth line, and this statement is getting printed. There is some error in the input, and then this done is getting printed. Now here this exceptional case caused by some statement in the try block, and the corresponding exception is getting handled inside this except block. Now the advantage of using this exception handling in Python is, even if there is an exceptional error occurring in the try block, the rest of the program codes will be executed. But for this code statement there is one limitation. Basically, as we have seen, if I am providing the second input as 0 here, it was providing me with the same error message, which is there is some error in the input, and even the same error message is also getting printed when I am providing the first or second number as string. So from this code we will be unable to understand what is the exact reason that is occurring, that is actually triggering the rise of the exception. Now a better solution or a better way of handling the exception will be to explicitly have a variable e which will be pointing to, which will be actually containing the exceptional case or the reason of the exception for which this exception or this error is happening. Now if I execute this code, you can see what in the earlier case I am just using the except block. Now what I am doing is I have written except exception, which is a generalization of all the exceptions that are defined in Python, and I am aliasing it as e, and I am printing the value of e here. Now if I execute this, say first number, if I say 12 and second number 0, you can see this e is division by 0. Now if I execute this, the first number, if I give a string, you can see this value of e is invalid literal for int with base 10. So basically this is the error that I am getting. So here, although there is an exceptional error occurring for the corresponding input, the execution of the rest of the code, in this case this only this eighth line done, is getting executed even if there is some erroneous statement occurring. Execution of erroneous statement is occurring in the code statements. Now still there is a limitation with this code as well. So in this code we were just printing that there is some error in the input, and I am just printing the error message or the exceptional error that is occurring here. But strictly speaking, we are not actually handling the exceptions in different ways. And to be precise, this is actually not a good programming mechanism to catch all the exception and handle all of them in the same way. A better way of handling this type of exception, multiple exceptions, is handling them separately with separate statements. Here I have written the same code, but instead of writing this exception as e or only the exception, what I have written, I have specified 3 separate except blocks. Here this except block will be catching the exceptional cases where there is a value error. This code snippet or this except block will be catching the exceptional cases where there is a zero division error, and for all other types of exceptions that may arise from this code snippet or this try block will be caught in this except block statement. Now if I execute this code statement, say first number, if I provide QWE, you can see this from this second line an error basically an exception has occurred, and it is actually transferring this execution of the code snippets to this 6th line. How? Because this is a value error type of exception. So, this value error type of exception will be transferred into this except block that is specified as value error, and this will be the statement that is getting printed. As you can see, in this code's block, you can specify whatever way you want to handle this type of exceptional cases. Now, if I execute this same block with say 34 and 0, you can see from this statement. So, I have taken two inputs 34 and 0. So, when I want to divide 34 by 0, one exception has occurred, which is basically 0 division error. So, the execution of the flow of the execution of the code is transferred from the line 4 to line 7, where this except block starts, and this can't divide by 0 statement is getting executed and is getting printed here. And after the handling of the, so this is basically the handling of the exception. So, after handling of the exception, you can see this done is getting printed here. Now, in this example, what we have done is we have handled these individual exceptions separately. Now, if you want, you can handle multiple exceptions together as well. This is the general framework of handling multiple exceptions together in a single exception block. Now, as presented in this example code block, if you want to handle multiple exceptions in the same way, you need to you need to follow this kind of notation. So, here I am handling the type error and 0 division error, which may occur in this try block in the same way. Although there can be multiple except statement or except code block in a single code, only one of this except block will be occurring at a time, and that except block will be triggered from the exception that is happening in the corresponding try block, and these exceptions will be only be rising when there is an exception or when there is a runtime error that occurs in this try block. Now, as we have seen in the example so far, the decision on when an exception is occurring is entirely taken by the interpreter, specifically the Python interpreter. But if you want to explicitly raise some kind of exception, you can use the raise keyword to raise explicitly some error at some point of time. Consider this example where in the try block I want the user to only type an even number as input, and if the input that the user is providing is an odd number or is not an even number, I want to explicitly raise the value error here. Note that this value error will not be not be the default one that is getting occurred here. I am actually explicitly specifying, or in a more formal term, I am explicitly raising the value error from this line. Now, look at the corresponding example here. If I execute this, enter an even number, if I specify an even number, it is okay, done is getting printed, that is stated in the 7th line. Now, if I execute again and if I provide an odd number or an input which is not an even number, you can see from this point I am actually raising this value error, and this value error is getting passed to the corresponding line 6, which is specified in this except block. Now, note another thing, here I am providing this as the argument to this value error function. So, here in this value error function I am providing, as we are providing this as the argument, this is getting transferred or this is getting passed into this VE parameter here or VE alias here, and whenever I am printing the corresponding passed error, whenever there is a whenever this line is getting executed, that is whenever this explicit raising of this value error is occurring, we are printing this corresponding message is getting printed. Now, again look at this example. You can see this done will be getting printed if there is no exception. Also, this done will be getting printed when there is this exception is occurred in this code snippet. Now, what if I want to print something, or I want to execute some statement which will be only occurring when there is no error or no exception that is occurring in the code. To do that, we need to provide one else code block after this except code block. So, here this else clause or else code block will only be executed when there is no exception that is occurring in this try code block. Specifically, if you want to execute some statement only if there is no exception occurring in this try block, you need to put this else code block just after this except code block. Now, in this example code, I want to get the reciprocal of a number only if the number that is taken as input from the user is even. So, this except statement will be executed by this raise exception block or raise exception statement, and this raise exception statement will be executed only if the number is not even. And in the except statement, what I am doing is I am just printing that the input that the user is providing is not an even number, and if the input is actually an even number, what I want to do is I want to get the reciprocal of the input even number. So, I have written this statement reciprocal equals to 1 by num in the else code block, and I am actually printing the value here. Now, look at the corresponding program. If I execute this, if I provide one odd number, you can see not an even number is getting printed, because as the provided input is 13, which is not actually divisible by 2, this statement is getting executed, raise exception, which is transferring the flow of execution from the line 4 to line 6, basically line 5 through line 5 to line 6, and in line 6, as you can see, not an even number is getting printed. Notice that here in this example, these two statements are not getting executed if there is an exception that is occurring in this try block. Now, if I re-execute this program again and provide one even number, you can see as there is no exception occurring from this try block, the execution flow is coming from this try block to this corresponding else block, where the input number is actually reciprocal, the corresponding reciprocal is computed of the input number, and it is getting printed here. Another optional clause that can come in a try statement is called the finally clause. This is the way we need to write these individual code blocks: try, then except, then else, and then finally. So, the code statements defined in this finally code block or finally clause will always be getting executed even if there is no exception or there is an exception occurring from this try block. The use of this finally block is if we are actually using or opening some resources from this try block, we should close or release those resources. It can be external, it can be internal. We should be releasing those resources from this finally code block. As an example, if we want to open a file for writing, then we should be putting the corresponding file writing statements in this try block. In except and else, we should be handling the corresponding errors, and in the finally block we should be closing the file. If we forget to do that, I mean if we do not close a file after writing some statements, it might be the case that all the statements that we have written in this try block will not be getting reflected or actually written in the file which is in the secondary memory or your hard disk. Now, the use of this finally can be confusing, because as we have seen earlier in our codes, this done statement was getting executed for all cases, like even if there is an exception or there is no exceptions, then why are we actually needing this finally block here? So, to actually see the difference why we need to have this finally block, here is an example code where I have written one function that is called receipt. I am providing one parameter here which is a number, and as earlier we have seen in the example, in this code as well, we are computing the reciprocal of the number if the number is even, and if the number is odd, we want to, I mean, in this program we want to print this corresponding statement that the user had provided with a number which is not an even number. Here I have provided one finally block here where I have only written finally cleaning and a print statement which is also in this function definition where I have written all went smoothly. Now, if I look at the corresponding code here and if I execute this, you can see there is no immediate output here. Now, if I call this function, if I call this function with say receipt with say input parameter say 14, if I call this function, you can see this receipt 14 is actually calling this receipt function with the parameter 14, and then in this try block it is getting checked whether the input number is divisible by 2 or not. As the input is not divisible by 2, this corresponding else code block is getting executed, where we have computed the reciprocal of the input number which is 14, and we are actually printing that reciprocal result which is here 0.0714 and so on. And as you can see, this finally cleaning is getting printed here, and all went smoothly is also getting printed after that. Now, you may get confused that this all went smoothly is always getting executed. Then what is the utility of having this explicit finally block here? It would be clear with another example. So, let us again notice this except block here. What I have written is, if some exception is getting raised from this try block, we are printing in the corresponding except block, we are printing a message which is not an even number, and then we are returning. Now, this return statement will be returning the flow of execution from this function to the calling function which is actually calling this function. This is the called function. So, this return will be passing or transferring the execution flow to that calling function. Now, let us re-execute the code. So, if I execute again, so if I change this 14 to say 13, now this 13, as you can see, 13 will not be divisible by 2. So, it should be raising this exception and the code block should be coming here. Now, if I execute this, as you can see, not an even number is getting printed, and this return is not actually directly returning the statement, the flow of execution from here to here, but in between this finally block is always getting executed. So, even if there is a return, the execution flow is not immediately returning from the called function to the calling function. In between, as there is a finally block, here this finally block statements are getting executed. In this case, there is only one statement. So, that is why this finally cleaning is getting executed. But notice that this all went smoothly is never getting printed here, because as we are returning, so after this finally, after the execution of this finally block, the execution will be coming back to the calling function which is here this receipt 13. Now, to summarize this try, except, else and finally blocks, what we need to do is we should be putting all the codes from where some exceptions can occur inside this try block. If the code in the try block is actually working, the code in the except block will be skipped, and if the code in the try block fails or there is some exception occurred from this try block, the execution flow will be jumping from the try block to the corresponding except block. If all the statements in the try block run smoothly, then the execution jumps from the try block to the corresponding else block after completion of all the statements in the try block. The program statements in the finally block will always be executed after the completion of the codes in try block, except block if there is an exception coming from the try block, or the corresponding else block as well. Summarizing the main components, that in the try block we need to keep the code statements from where some exceptions can occur. In the except block we need to handle the corresponding errors or the exceptional cases, and in the finally block we should be cleaning up, that is we should be releasing the resources that has been allocated in the try block and so on. The practical example in which this exception handling is necessary is when we want to read or write a file from our Python code. For reading a file, we should be putting this f equals to open with the file path as well as the mode in the try block, and in the finally block we should be closing the file. This is the example of releasing the resource. Here I am I am kind of allocating one resource for our use in this try block, in this case which is opening the file, and if I open a file I should be closing that file. So, that corresponding closing is kind of releasing that resource, and that statement should be there in the finally block. Correspondingly, to write a file we should be opening the file in the try block with the W mode, and in the finally block we should be closing that file so that to ensure that the files are saved properly. As an exercise on utilizing this exception handling, this try, except, else, finally statements in your code, I would request you to write a program that will take some names from the user as input and write those names in a file. Note that we should be opening the file from the try block, and we should be having a finally block in which we should put this f.close statement to ensure that the file is saved properly.